We are at the Ocean Institute, and they have this fully articulated gray whale that washed up on Huntington Beach many, many years ago.
So let's start at the top here, start at the skull. So you can see that this skull is quite a bit smaller than what we saw at the bone warehouse, right? So we already know that it's going to be a younger animal. And they actually don't become sexually mature until they're between 6 and 9 years old. So at 2 years old, this isn't quite a subadult, it's more like a juvenile. But you can see the curved part of the upper jaw and the lower jaw down here. Remember that the baleen would be hanging down from here. These animals evolved from animals that lived on land, and so they had or have similar structures than what we have. But here you can see analogous bones to what we have. So this is a scapula, which would be our shoulder blade right here, and it's massive, right? Because they have to be able to swim through the water, and water is a lot of force. There's a lot of force against the water.
So if this is the shoulder blade,
right?
Is this the arm?
This is the humerus.
Oh, that's
right here.
That's the upper arm.
Yeah, that's the upper arm. That's the humerus.
Very cool. So
and this is the radius and ulna right here,
so
just
right
like
here,
us.
your forearm.
Yep. And then these are the fingers or the phalanges. So if you looked at our bones, it would not really look anything like this. I mean, our humerus is much longer. Our radius and ulna are not as stout, and our phalanges aren't quite that long. And the reason why you want something like this is for two reasons, actually. One is the bones have to be much thicker in order to go against the force of that water. So they have to be able to have muscle attachments and ligaments and tendons, and so they have to be much thicker. But the other thing that you really need in the water is to be streamlined, right? So that you can swim really efficiently. But if we look down here, these are the remnants of our pelvis. They don't have any leg bones anymore. It's not that they're missing from the skeleton, it's that they actually have lost them over evolutionary time because they don't need them because they don't walk on land. So they still need the arm bones, but they really don't need the leg bones.
So if they had legs, it would create lots of drag.
It would create lots of drag, right? So over time they've lost them, and all that's left are these little vestigial hip bones, which are amazing that they're still there because they're not needed for anything. Yeah, they're not needed for anything at all.
Now this leads down to the tail.
Right.
But the tail isn't here.
That's right. So
come on.
The reason why the tail isn't here is because the tail does not have any bones in it. So the skeleton would end kind of like in the middle of what we call the tail fluke, and then the fluke is made of cartilage, which when you're digesting tissue, when you're trying to keep a skeleton, you're going to digest that cartilage away. So if you ever see a skeleton like in a museum and they show the tail flukes, it's because it's like plaster of Paris or something like that, where they've added that so that you can actually see what it might look like. But
so the fluke is really the propeller of the whale.
That's correct, yeah.
So, and they're moving that up and down through the water, and then that generates thrust and lift.
Yes, I remember we talked about those epaxial muscles and the hypaxial muscle, right? So the epaxial muscles are connected to this neural process, and they don't ever push, they pull. So they're going to pull the tail up. Those epaxial muscles pull the tail up with this very strong connection to the neural process, and then the hypaxials will pull the tail down, and that's how they get the up and down. Okay, let's look at the ribs. So these are real rib bones, just like we have, and the ribs are really important for protecting the internal organs, right? So just like us, we have to have ribs to protect our internal organs, so they haven't lost any of those.
So every time it takes a big breath, its lungs inflate.
Yeah.
And this thing has to expand.
A little bit, yeah.
So these are hinges that allow the body to expand when the lungs fill with air.
But they don't need to take big breaths like we do, right? So like if we're gonna say dive in a pool, we go and we expand our rib cage and our lungs. They don't really do that. So they're so efficient at their oxygen storage. So they can store oxygen in their muscles and in their blood way more than we can. So they really just take a normal breath. They come to the surface, take a breath, and then they can dive down for 20 minutes.
Now what about the neck? I mean, their vertebrae are so close there, so it can't really turn its head, can it?
No, and it doesn't want to, right? It doesn't need to. It really needs to be streamlined. It doesn't need to be moving its head all around because really it's preying on things that are in the mud at the bottom, right? So it's not like it's like Flipper that's moving around looking, oh, there's a fish over there, oh, there's a fish over there. It really doesn't want to do that. It just wants to be very streamlined when it's swimming, migrating up the coast, migrating down the coast, feeding off the bottom. It just sucks up the mud, sucks it in, and pushes the mud and the water out and gets the amphipods.
So when we're in the lagoon and we're in the pongas and the whales come up to the boat and they stick their heads out of the water, they can't turn their head. Really.
No. And the whole body really comes out of the water.
Right.
It's really most of the body that's coming out of the water. They can turn and spy hop and look like that, but they're not twisting their head to the left and right.
No.
Here you can see that they have many more vertebrae than we do. They also have these compressed vertebrae in the neck, which don't look like ours, and that's because they have to hold up that really big head in the water.